Welcome to the deep dive, where we really try to unravel the complex stuff. Today, we're jumping right into Web3, this idea of an internet controlled more by users, powered by network tokens, all built on blockchain. And what's really interesting now is how AI is starting to make these pretty complex systems feel, well, usable.
Exactly. And for you listening, wanting to grasp these big shifts without getting lost in technical terms, well, that's what we're aiming for. We're pulling out the core ideas of Web3 and blockchain from our sources, looking for those key moments, build that solid understanding. We'll touch on a bit of the history, too, and try to clear up some key terms.
Yeah, because let's be honest, Web3, crypto, blockchain, they get mixed up all the time, right? It creates this fog. So today, this deep dive should cut through that, show that Web3 is like a much bigger idea than just digital money or even just the blockchain tech itself. Okay, so maybe let's start by looking back a bit, how we got here. Web 1, Web 2, to set the stage.
Good idea. Think way back, the early internet, Web 1. The read-only web, mostly.
Yeah.
Websites were pretty static, sitting on central servers. You navigated with browsers, search engines were just starting up. The big deal then was HTTP, HTML protocols that let people make websites and link them. Revolutionary for accessing info, but very one-way.
Right. And then came Web 2, the read-write internet. That's pretty much the web we know now, isn't it? Fueled by better infrastructure, smartphones everywhere, social networks, online shopping, all that stuff.
Exactly. And the key model there is client-server. We interact, create content, generate data.
Yeah.
But ultimately, the platform operators, the big companies, they control that data centrally.
Okay, so that brings us to Web 3. It's positioned as a potential shift away from that centralization.
That's the core vision, yeah. A more collaborative web, more user-centric. The idea is using these network tokens to incentivize participation, kind of merging networking with actual computation. It's trying to fix that power imbalance, that data control issue inherent in Web 2. That's why the idea of a decentralized Web 3 is pretty compelling.
So let's get into the tech that supposedly makes this possible. Blockchain.
Right, the foundation.
Our sources call it a publicly verifiable, collectively maintained digital notary and accounting machine. Sounds robust.
It is. And it really
Yeah.
started the spark anyway with the Bitcoin white paper. The main problem they wanted to solve was peer-to-peer digital money. No banks needed. How do you stop someone spending the same digital coin twice without a central checker? That's the double spending problem.
Okay.
Their solution used cryptography and really clever economic incentives. It showed you could actually build trust algorithmically in a network where you don't inherently trust anyone. That was huge.
And it's grown way beyond just digital money now, hasn't it?
Oh, absolutely. Bitcoin was just the start. Blockchain tech has become this general-purpose infrastructure. It can manage all sorts of tokens representing different kinds of rights, property, access, voting in a community, information, you name it.
So when we hear public and permissionless network, Bitcoin is kind of the classic example.
Exactly. Anyone can join in verifying transactions. Anyone can use the network. No gatekeepers. And this openness, kind of unintentionally, created a new kind of decentralized institution. The rules aren't set by a company. They're baked into the software protocol itself. And they're enforced by this distributed network of computers, the nodes.
So the protocol is like the constitution for this digital network, defines all the rules.
That's a great way to put it. The computational constitution.
It spells out how participants are identified, what makes a transaction valid, how people get rewarded for helping run the network, even how the rules themselves can be changed.
And the network nodes are just computers running this software.
Yep. Computers executing the protocol, doing the work of verifying things, maintaining the ledger, and they're usually incentivized, often with the network's own tokens, to do that work, honestly.
Okay, got the rules, got the enforcers. How's the actual chain built?
I'm picturing, well, blocks in a chain.
That's basically it. Transactions get gathered together into these blocks. Then those blocks get added sequentially onto the blockchain. With Bitcoin, for example, a new block gets added roughly every 10 minutes.
And inside each block, just transaction details.
Transaction details, yes, plus cryptographic signatures proving who sent what to whom. Very important.
And then there's the hash, that unique code for each block.
Exactly. Each block gets a unique digital fingerprint to the hash. It's calculated from all the data in the block. Change even one tiny detail, and the hash changes completely. It's like a digital seal.
Okay.
And here's the chain part. Each new block includes the hash of the block that came just before it.
Ah, so they're linked cryptographically.
Precisely. Creates this unbroken chain going all the way back to the very first block, the Genesis block.
Mm.
So if someone tried to tamper with an old block, its hash would change.
And that would break the link to the next block because that next block expects the original hash. The whole network would see the mismatch.
You got it. Tampering becomes instantly obvious. And changing it would mean recalculating the hash for that block and all the blocks after it across thousands of computers.
Which sounds computationally massive. Basically impossible for one actor.
Practically impossible, yeah.
Yeah.
Requires immense computing power, and you'd need the majority of the network to somehow agree to your fraudulent version.
Mm-hmm.
Highly unlikely. So this growing chain of linked, secured blocks is the ledger, the blockchain itself, a public, verifiable record.
I liked the analogy one source used, like a shared spreadsheet, maybe Google Sheets, but instead of Google managing it.
Is managed by all the nodes on the network together.
Right.
Yeah, it's a helpful visual. And unlike a bank's private ledger, this one, for public blockchains, is open. Every node has a copy. It's like everyone's a notary. Super useful when different organizations need to coordinate but maybe don't really trust each other. No central middleman needed.
Okay, and when we say token or coin, like Bitcoin, it's not actually a file I hold.
Correct. It's more like an entry on that shared ledger, a status of ownership. It's linked to your specific blockchain address, and you control it with your private key.
The private key being the secret code that lets me prove it's mine and sign off on transactions.
Exactly. It generates your digital signature. That's the crucial bit for security and control.
Okay, but in a system with potentially anonymous people, how do you stop bad actors? You mentioned something earlier, the Byzantine generals problem. Sounds dramatic.
Yeah, it's a classic problem in distributed systems.
Yep.
How do you get a group of actors, some of whom might be unreliable or even malicious, to agree on one single truth, like generals surrounding a city needing to coordinate an attack? Before Bitcoin, the common thinking was you needed a central commander, a trusted authority.
But Bitcoin cracked it somehow, without a central authority.
It did, using proof of work. That's its distributed consensus mechanism. It mixes cryptography with tasks that require a lot of computational effort work. This makes cheating incredibly expensive. The idea is the cost in energy and computing power to try and defraud the network vastly outweighs any potential reward, and you'd likely fail anyway.
So consensus mechanism is just the network's way of voting, essentially, agreeing on what's valid.
That's a good way to think about it, yeah. How they reach agreement on transactions and the order of blocks. And the whole field studying how to design these systems using crypto and economics to keep everyone honest, that's crypto economics.
Crypto economics, interesting. So it uses both tech and financial incentives.
Exactly. Cryptography secures the interactions, and economic incentives encourage good behavior and punish bad behavior. It's a really fascinating blend.
So the security isn't like one big bank vault.
Yep.
It's more distributed.
Right. Breaking into one central place is one challenge. Trying to simultaneously break into thousands or millions of independent, globally distributed nodes running the same protocol, that's exponentially harder. And account security uses decentralized public key infrastructure. You generate your own keys, no central admin issues, passwords, or anything.
Okay, and these blockchain wallets people use, they don't actually store the coins, you said.
Correct. That's a common misconception. The wallet is software. It manages your addresses and, most importantly, your private keys. It lets you create those digital signatures to send transactions. Think of it like a secure keychain and a way to interact with the network, not a digital piggy bank.
And since it's a public ledger, can everyone see my transactions?
On public blockchains like Bitcoin, yes. The transaction data itself is transparent. Anyone can look it up using a block explorer.
A block explorer, like a search engine for the blockchain.
Pretty much, yeah. You can see transactions, addresses, amounts, block details. But crucially, the addresses themselves are usually pseudonymous. They aren't automatically linked to your real-world identity unless you choose to reveal that connection somehow.
Got it. Okay, we've talked transactions. What about the overall picture, the state of the network? Like, who owns what right now?
Yeah, state is fundamental. In computing, it just means the current information. Who's who owns what, who can do what on the network. Now, the basic internet protocols, TCP/IP, HTTP, they're mostly stateless. They're great for sending data packets back and forth, but they don't inherently track ownership or rights. That's why we've always needed intermediaries, banks, social media platforms to manage accounts, and digital property.
So things like website cookies and Web2, they try to remember state, like my login.
Yeah.
But the website owner still controls it.
Exactly. Cookies help locally for that session. But the real record, the control, is centralized with the service provider. What Bitcoin did that was so radical was introduce a way through its consensus and ledger to manage state natively on the internet. The blockchain itself becomes the agreed-upon record of who owns what, updated collectively. This enables peer-to-peer value transfer without needing those old intermediaries.
Which leads to another key idea: transaction finality. How sure can I be that once I send something, it's truly sent and can't be taken back?
Yeah, finality is crucial for any economic system. You need confidence the deal is done. Think about cash finality is instant, right? Hand it over, it's done. Checks, less so they can bounce. Old credit card slips took time to process. Even modern electronic payments, while they seem instant, often have back-end processes and intermediaries involved.
So how does blockchain finality compare?
It's a different kind of finality. Once a transaction is in a block, and that block is confirmed on the chain, reversing it becomes incredibly difficult, as we discussed. But how final it is can vary. With proof of work like Bitcoin, it's usually probabilistic finality.
Probabilistic, meaning there's a chance it could be reversed.
A tiny, tiny chance initially.
Yeah.
But as more blocks get added after the block containing your transaction, these are called confirmations, the probability of it ever being reversed drops exponentially. After, say, 6 confirmations on Bitcoin, it's considered extremely secure, practically final for most purposes.
Okay. And the alternative is deterministic finality.
Right. Some other consensus mechanisms, like many proof-of-stake systems, aim for deterministic finality. Once a block is agreed upon by the validators according to the protocol rules, it's considered absolutely final, instantly. No probability involved.
Sounds simpler, maybe better.
It offers stronger immediate guarantees, which is appealing. But these systems can be more complex under the hood, and there are ongoing debates about potential trade-offs, maybe around decentralization or complexity.
Fascinating. Okay, one last big topic from the sources: protocol forks and network splits. Sounds like drama in the digital world.
Huh. It can be. So a fork in software just means taking the code and modifying it. In blockchain, an external fork is when someone takes an existing blockchain's code, copies it, maybe tweaks it, and launches a totally new, separate network. Different goals, different community. Think Litecoin or Zcash, which originally forked from Bitcoin's code but are now distinct blockchains.
Okay, so a whole new project. What about internal forks, changes to the existing network?
Right. These happen within an established blockchain. You can have technical internal forks. These are usually just upgrades, improvements to the network, like a software update. Generally not controversial. Node operators just update their software. If not everyone updates at once, you might get a brief, temporary split, but usually the network quickly converges on the new rules.
But then you mentioned political internal forks. That sounds contentious.
They definitely can be. This happens when there's a major disagreement in the community about how the protocol should change. If the disagreement can't be resolved, the chain can split permanently. One group follows the new rules, the other sticks with the old. Both resulting chains share the same history up to the split point. And if you held tokens before the fork, you usually end up with tokens on both chains afterwards.
Yeah, like getting double.
Sort of, but the value isn't necessarily doubled. The minority chain, the one with less support, needs backing from exchanges and users to survive. Bitcoin Cash, splitting from Bitcoin, or Ethereum Classic from Ethereum are big examples of this.
Okay. And then economic forks, driven by money.
Yeah, these are often seen as less about genuine technical or philosophical debate and more about, well, creating a new coin to potentially profit from. Someone might fork the code, create a new tokens, generate some hype, maybe distribute it to existing holders of the original coin, and then perhaps sell off their own stash. Sometimes called a rug pull if it collapses quickly. Things like Bitcoin Gold or Bitcoin Diamond have sometimes been viewed through this lens, though motivations can be complex.
And finally, temporal splits, just temporary glitches.
Pretty much. Accidental, usually. It can happen if, say, 2 miners in different parts of the world solve a block at almost the exact same time due to network lag. For a moment, you might have 2 competing tips to the chain, but the protocols, like Bitcoin's, have rules to resolve this. Typically, the chain that gets the next block added to it first becomes the accepted one, the one with more accumulated work. The other short branch just gets discarded. The network sorts itself out.
Wow, okay. That covers a lot of ground. It really paints a clearer picture. So Web3 is this vision, this goal of a more user-centric internet. Blockchain is the underlying tech making decentralized management of value and rights possible. And all these mechanisms, consensus, crypto, incentives, fork resolution, they're the engine parts making it secure and functional.
That's a great summary. And understanding these fundamentals gives you, the listener, a really powerful lens. It helps you look past the hype or the fear sometimes and evaluate what's actually happening as the internet continues to evolve. You can better understand the forces at play.
Definitely. So maybe a final thought for you to chew on. We've talked about finance, but given this power of blockchain to manage digital rights, to allow direct peer-to-peer stuff, what are some of the really unexpected ways you think this technology could change things? Online, offline, things maybe we haven't even considered yet. Something to ponder. Thanks for joining us on this deep dive today.